We have discussed about different clipper circuits, biased clipper circuits, unbiased clipper circuits, and also we discussed about the transistor clipper circuit. This time we are changing the clipping element. Here we are taking a specially designed Zener diode. So Zener diode is a PN diode. Both P region and N regions are heavily doped, and the depletion region width is very much low. Because of the heavily doped regions, the electric field, if we give the strong electric field, it can even break the covalent bonds and the electrons may come out, thereby forming the electron hole pairs. In the reverse bias, especially after the breakdown regions, the normal diodes are not able to work. But Zener diode is a specially designed diode. In the reverse bias, it will work even after the breakdown region. So it starts conducting the after breakdown region. Normal PN junction diodes, if we operate after the breakdown region, they will get damaged. But Zener diode, in forward bias, it will exhibit like a normal PN diode characteristics. But in reverse bias, after the breakdown region, if you are trying to change the input voltage, the output voltage will not be changed, but the output current suddenly changes. So we say Zener diode starts conducting after the breakdown region even if it is connected in the reverse bias. Here we have considered a single Zener diode, a resistor. We are giving a sinusoidal signal. As we already discussed, these are non-linear wave shaping circuits. There is no necessity to give only square wave. We can even give the sinusoidal signal also. But for linear wave shaping circuits, if we give the sinusoidal signal, output will be also sinusoidal. We might not able to understand the circuit functioning. That's why for the linear wave shaping circuits, we are giving the square wave as an input. This is the sinusoidal signal. When we are giving the during the positive half cycle, after a particular voltage, you see the Zener diode is reverse biased here. When I am giving 1 volt, this Zener diode is reverse biased. After a particular voltage, example, if this Zener diode breakdown voltage is 4 volts. After the 4 volts, this Zener diode, even though it is connected in reverse bias, it starts conducting. So whatever may be the input voltage, now the Zener diode will act like a battery only. So the output voltage will be clipped at the 4 volts. So here Zener diode is acting like a battery source after the breakdown region. During the negative half cycle, when we are giving minus 0.1, this will be in the reverse bias only. Diode will not conduct. When it is minus 0.7 or minus 0.8, diode starts conducting, it is in forward bias. Because the diode starts conducting, the output voltage will be entirely grounded. There will not be any output voltage. Only that forward voltage drop 0.7 volts will appear. So in the negative cycle, we get only 0.7 volts practically. In the positive cycle, the clipping amplitude, the peak amplitude will be decided by the Zener breakdown voltage. If the Zener breakdown voltage is 5 volts, then we will get the positive signal until the 5 volts. At the 5 volts, the positive half will be clipped. If we are taking two Zener diodes, the cathodes of these two Zener diodes are connected with each other. This is Zener diode 1 and this is Zener diode 2. When we are giving this input signal, example, if this Zener diode breakdown voltage is 4 volts and this Zener diode breakdown voltage is 5 volts, when we are giving a 1 volt signal, for that 1 volt signal, this diode will be forward biased, but this is reverse biased and it will not conduct. So whatever the input we are giving, that will appear across the output. That's why you see it will appear across the output. If we are giving the more positive voltage, the example we have given 4 volts positive voltage. This is forward biased, this is reverse biased. Still it will not conduct. The output will be same as the input because there will be no current across the resistor. and still we have increased the voltage to 5 volts. The input voltage now is 5 volts. When we are giving the 5 volts, this is forward biased. This is reverse biased. This is in on state because it is forward biased. This is also in on state because even though it is connected in reverse bias, the reverse breakdown voltage obtained. That's why this will be also in the on state only. So finally, it acts like a 5 volts battery source and it acts like a 0.7 volts battery source. So 5.7. This will be clipped at DZ2. Diode, second Zener diode's breakdown voltage plus forward voltage drop of the first Zener diode, 0.7 volts. This is how the positive, during the positive half cycle, the peak will be clipped. Second Zener diode's breakdown voltage is deciding the positive peak amplitude. Based on this breakdown voltage only, the positive peak will be clipped. Similarly, in the negative, during the negative half cycle, if we are giving minus 1 volt, minus 1 volt means this will be in the off state. So whatever the input we are giving, that will appear across the output. Similarly, minus 2, minus 3, when I am giving the minus 4 volts, it is reverse biased, but it still starts conducting because its breakdown voltage is 4 volts. So at minus 4 volts, it starts conducting. When we give the same minus 4 volts to here, because it is in on state, this diode at the anode we are having 0 and cathode minus 4. Already it is in conducting state because it is forward biased. This is reverse biased. It is reverse biased, still it starts conducting because after the breakdown voltage, it starts conducting. That minus 4 at the cathode and 0 at the anode, it is in forward bias, it starts conducting. So the final clipping voltage will be minus 4 minus 0.7. So this will be DZ1 plus DZ1 minus 0.7. This will be minus 4 volts and minus 0.7 volts. The clipping level of the negative half cycle will be decided by the Zener diode 1. Zener diode 1 breakdown voltage decides the clipping level during the negative half cycle. This is how we can design a double-ended clipper by using a simple two Zener diodes. Zener diode is capable of operating even after the breakdown region. We are taking that property. We are utilizing that reverse breakdown voltage property to design this Zener diode clipper.